Okay, welcome folks to another session of SDE Skills. Today we are going to do a mock interview. Chavi is going to be the interviewer and Sai is going to be the candidate. Initial 40-45 minutes they would do the mock interview, followed by there would be feedback and any design discussion. With this, I would going to hand over it to Chavi and Sai.
Hello, Sai. How are you?
Hey, Chavi, I'm good. How are you doing?
Doing good. So yeah, maybe we can just jump into what we're going to do today. And we are going to design a task scheduler.
Okay. Um, okay. So do you have, is that it, or can I come? I mean, do you have any more requirements, or can I follow up you some of the requirements that I may need from you?
Yeah, sure. We can start with what you think a task scheduler does, and
Okay.
I can chime in if you have questions.
Yep. Just a second. Okay, so I don't know why I'm not able to. Okay, sorry. Okay, probably like sorry for the technicalities. Okay, task schedule is the topic. So what I think in broad is like there could be n tasks which you might need to probably align, and you will be having a let's say there are like.
I cannot see if you're typing something.
So sorry. Okay, probably.
Do you want to click on A? That is where you can start writing. Yeah. Yeah, I can see now.
Okay, great. Okay, so let's say there are n tasks, right? And probably if we have. Okay, again, I can't write it. Sorry, real sorry for this. Okay, let's say there are n tasks, and probably you might want to do them either parallelly or serially. So probably in order to define maybe like priorities and see how things are better worded, I think that we may need a task scheduler. I would like to know more like what is the requirement.
So let's say for priority for now, every task has the same priority.
Oh, okay.
Right? Let's for simplicity, we can start with that.
Okay. Okay, so probably what are we building? Are we building an web application or something else? What is the end goal?
So different services or a user can like submit tasks, and the system should be able to run those tasks at that specified time. And so the configuration of the time can be whether it has to be done in 1 hour or every day 1 hour, like at 8 a.m. Or at the first of every month, or just once a year. So they can be like different frequencies that a user might want to run these tasks. So it can be only once or it can be repeatable.
Okay. I think there is okay. That's good. To begin with, that sounds good. Yeah. Okay. Basically, it's a task that needs to be submitted, and it has like whatever the unit interval of time that we need to run. That is good. And can I equate this to something like an Airflow or a Jenkins job in reality?
Jenkins, Jenkins, from what I understand, aren't scheduled for future. They are just put in a queue.
Okay.
And then however the system finds resources, the tasks are run. So these tasks are a little different in the sense that I can say, okay, next Sunday at 10 a.m. run this task, or every morning at 8 a.m. run this task.
Okay.
So yeah.
Okay. Okay. I see, like we probably need some kind of an future scheduling over here. And yeah, I mean, just to ask you, like, do we have any? Is it like we are building for a startup, or do we have already existing system that we need to build, or how does that work? I'm just thinking about the number of users here.
Well, let's say you have anywhere around 100 to 1,000 requests per minute.
Oh, okay.
So let's start from there and let's see how we can scale later.
Okay, that's good. And any idea on like approximate time on how much approximate time each job runs? Can it vary, or any approximation?
Let's keep the to 1 hour average time.
1 hour average time. And are there any like super users that can like probably change the priority? I mean, stop or schedule, or like even start something?
So we can start with just scheduling, but I want you to think also that a user should be able to say that, okay, stop this task from next week, or or maybe just stop it right now, so the next run of the task would not happen. So if a user, so just think about them, but we can start with just one request of scheduling and we can build from there.
Oh, okay, great. I think I have got a decent idea on what the requirement is. So probably I will go ahead and define some of the functional requirements which I have gathered from you. Schedule tasks at future or unit interval of time. And I can think probably in okay, same priority. Okay, let me right away jump into the non-functional requirements. Definitely we are, since you mentioned that probably we can scale it later, definitely we should like think about scalability in the picture. And also like it is around like 1K requests per minute. Okay. And so probably I'm thinking it is more of an AP system, which is like in terms of cap, consistency, availability, and partitioning. Our scheduler should be able to, as long as we schedule, the scheduler should be able to schedule the task at the cost of consistency. So I'm thinking it is an AP system. And definitely reliability is one of the key factors that I would think over here.
When you say cost of consistency, what do we mean here?
Okay. Let's say it is important to let's say there are like 10 or like 100 more jobs scheduled at this exact same second to be run. It's okay for me to run maybe a couple of seconds here and there, but to schedule a job, the system should always be available so that I should be able to schedule a job if it comes to the resource constraint for the consistency of running the jobs at the same time.
Okay.
Okay. What else can I think of over here? Okay, I think this looks reasonably good. So okay, let me share on how I wanted to proceed further. Probably we can start with some kind of an DB schema on how it works, and get ahead with the API design on how we would be designing the API. Then we can come to the architecture probably we can deep dive into each one of the whatever the microservices architecture if it is required, and then we can think about the scalability and whatever the data hotspots that we might face over here. If that is okay, probably I would start with the DB schema.
Sure.
Okay. I'm just thinking loud over here. Okay, possibly a question to you, like since there are many users, so is it assumed that the users are logged in?
We can assume that whoever is kind of be able to reach this API is already an authenticated user.
Oh,
don't worry about authentication here.
Okay, makes sense. So let's say like probably I will have some user profiles actually where I would be storing whatever the account management, right? I'm not much interested in digging into it, but I just wanted to code it over here. And probably the history of runs which he had. So, and that is the user table which I'm thinking over here. And just user ID is generally like there could be many other services which you could get the user ID, or like maybe 4-byte will do around like a 5 million, or sorry, 5 billion actually. So probably I will just go with like a 4-byte, and the creation timestamp is again 4-byte. History of runs can be like a simple history of runs. When did what is the DAG, what is the name of the job? Basically it covers the name of the job. So name of the job can be usually like 10 bytes or like probably 20 bytes at the max. So this is not a heavy this is not a heavy table, combined together 30 bytes. And probably since what are the number of probably a question to you, like what are the number of users that we are talking? Since you said it is like 100 to 1k requests per minute, but I just wanted to get a feel of what is the scale of users that we are talking here.
So I would say let's focus on how much requests we are getting and not on who is scheduling it, because it doesn't matter to our system.
Okay, makes sense. Okay, fine. Then probably let's see what is the let's see what is the table that we need to create for that, right? Probably just thinking loud, we need a okay, what is that task ID, right? That we want to schedule, and what is the time of the start the task needs to be scheduled, and probably the task name. What else can I think? If ever we come in the future, probably we could reuse this label. And okay, given a task and whatever is the user ID that it is he's running, starting the job probably. Yeah, I mean this is the table which I think, a schema which I think for it. Probably thinking loud, a 4-byte of timestamp. Task name can be like a 20. Priority can be a probably maximum of 2 bytes. User ID again will be a 4-byte. So yeah, I'm not envisioning a heavy data oriented table over here. Probably I will go ahead with this schema for my database, and I want to see the how my API, how I can design the API, if that is okay with you.
Sure.
Okay. Okay, so probably something like schedule tasks, right? For the scheduling of a task, I definitely need an user ID. I can think whatever is the time start. It can be a null, none basically. It could be started immediately. The default value is let's say it is now. And what are the other things? We definitely need the task ID over here and
So
priority.
task ID should be the one your system should be generating, right? Not the user should be giving you that. Or do you expect user to give you the task ID?
So I'm thinking something like user should be able to click on a task and click the button run. So that should give me what is the exact task that the user wants to run.
But if it's a new task that they want to submit, that's not there in whatever list you are showing them. So we want a user to be able to submit tasks, right? Not just run already existing tasks.
So okay, that's good. So in that case, I either need to know the name of the task, or at least I need to know what is the ID of the task to run it. Is that a fair assumption?
I mean, it's your schema to decide how you're
Okay.
going to uniquely identify a task.
Okay.
But I would, yeah, I mean, go ahead. We can discuss it if there is a
Okay.
concern later. Yeah.
Sure. Okay. Here the assumption. Let me quote here. Assumption is like at least a user knows the task name or task ID. So let's go with the task ID that which he know. So probably that will.
Yeah. So I'm trying to understand why we assume that a user should know a task ID or a name. I am a user and I want to tell your system that this is this bash script that I want to run every weekday at midnight, right? And this is what I want to submit to this system that we are building. So how would I know? Task name is something you can obviously maybe make mandatory, right? That you need to give me a name. But how would I know the task ID?
Okay. Fair enough. Okay. Then okay, let's name it as like a task name, right? Probably I will have like a task name comma task ID as a lookup table. If it exists, probably I can use the other table to get the details or fill up the other table. If not, like probably I will create an entry and get a new task ID, and then I will fill the other schema. So does that make sense?
Yeah, I see that your table already has task ID and task name there. Why do you want this another table?
Okay, so here, okay, so there can be a possibility that two tasks might have same name actually. So I want to make sure I am assigning a unique ID for each one of the tasks, and that is how I want to distinguish them. So this table has like a task ID as the primary key. Initially, when we started, I thought that probably that would be a good design. And since you mentioned that the user should be giving a task name, then I'm thinking in this direction.
Again, I mean, that is your call if you want the name from the user. That is not a requirement that that the system has.
Okay.
You are building the API, so you decide what you want the user to provide.
Yep. Definitely task name. Okay, if the task name, okay, just thinking little bit further, right? Maybe 30 seconds. Like, if the task name is unique, if the task name is not unique, how does the scheduler know which task he or she is scheduling, right? So there will be a conflict here. So probably we need to resolve that before even proceeding further.
So won't your task ID help in that, uniquely identifying a task?
Okay, from the user point of view, we are just giving these parameters, right? So if the task name is itself can be if there are like let's say let's say that there could be like a task name which is duplicated, right? How would I know which task the user is trying to schedule?
Okay. So if a task name is duplicate, you're gonna give an error back to the user.
At least probably I will throw error saying that okay, okay, these are the two tasks you might need to choose. Okay, maybe choose one of them actually. Or like which one do you want to, and I can probably give some radio buttons and let it choose. Let them choose.
When you say two tasks, how like I'm again trying to understand that this is the first time a user is submitting a task, right? Let's say a user says, okay, I'm submitting this task or run this bash script starting 1st of September, right? Every day midnight, right? That's the first time I'm submitting this task. So why would you give me a choice of two tasks that are already existing?
Oh, okay. That makes sense. So like let me go ahead with this.
So I think there is a little gap in understanding. We are not only asking users that this is a list of tasks and you choose what to run. No, we are asking users can give me a task and then my system would make sure it runs on that future time that the user has specified. And if they have specified that it has to run periodically, then my system should do it automatically. User will not come again and tell me, okay, run it again at 8 a.m., run it again at 8 a.m. No, right? They'll not do it. My system has to take care of that. If the user wants to run it every day, my system should run it every day.
Okay, that makes sense. That clarifies many things. So, then like okay, probably we need the content of the task itself, and probably since this is a one-time thing, okay, probably okay. So what the input I would expect from the user is like probably the user ID and whatever is the task content or whatever is the it could be if he wants to provide the name, that is good, and whatever is the start time, and whatever is the urgency, right? Since we are not talking about that is fair. So in that case, let me scrap this off. Yeah, the bash script gives me a good example over here. Okay, this is the API I would use for scheduling a task, and probably okay. Once I schedule a task, what should it return? Possibly it will return a boolean, or like maybe in logs we could throw some more detailed explanations actually in case of failures or like success. What else I could think of? So this is the API that I can think. Yeah, possibly like I just want to, if this API is okay for you, then I would like to move to the architecture.
Sure.
Okay.
Move ahead.
Okay, so since this is like okay, possibly there could be many users could try to start with the many users who may hit our system. So I will probably have a load balancer, and probably I don't want to dig many things into API gateway. Rather than I will just say like there is some assuming that the architecture is scalable, I will think something like a data ingestion service. What it does is like it takes the API. Sorry, okay, it takes the input of everything, and probably I will have something like an short URL service over here. The reason behind it is like the content of the, since you said that it's a batch service, right? Probably I just don't want to pass it on to the entire thing. Probably I will store it somewhere, and I will put the things, everything into a queue. Here is my queue. There are many queue out there. Probably something like a Kafka or a message queue over here.
Sorry, what is the short URL service? What is
okay. So what it does is like as soon as I receive any data, this will generate a short URL, something like bit.ly or
Okay.
so all the content will be hidden and will be stored, and I would just pass on the URL so that maybe in the future purposes, I will, whenever I need the content, I will go to that URL and decode and get back to this entire content.
Okay. So where will the content live of this bash script?
Yep, that's good.
Mhm.
Yeah, so possibly I will have some kind of an DB. I'm thinking more towards a key value DB, where the key itself is the URL, and probably the value itself is the content, and probably I can reuse it, and I can always store it, and I can get back if it is needed actually. Data.
Okay, this short URL service is gonna write to this key value store, and the data ingestion service is gonna read.
Yes. Yeah.
Okay.
Yeah. Yeah. So basically, first, whenever the data comes, it will ask the short URL, pass both the content. First, pass the content, and as soon as it passes the content, this will create a short URL and put everything in the DB. And as soon as it gets, basically, this data ingestion service will get a short URL. And in the future, if it wants to just read it, probably we can get it from there, or maybe for verification purposes, whether if it already exists or something like that.
Okay.
Okay. So once I will put everything in a queue. Once I put everything in a queue, because it itself has like its own cluster management and everything. I'm thinking more of a building a my scheduler service. Usually it is a processor, which itself is a I think is a scheduler service over here. What the scheduler service does here is like it has like its own inbuilt algorithms, basically inbuilt data structures, which I am tending to use like a DAG, which is like a directed acyclic graph over here. So probably
for what are we using this data structure?
okay, so there could be a possibility that a single task might trigger another task. Okay, so I want to make sure that I start and stop my first task, or like a task could combine like several of the subtasks, and each one of these subtasks might need to be run parallelly or might need to be run serially, assuming that I have all the instructions in the bash script over whatever the user has provided. So I want to make sure I run them in a I want to make sure that I use the directed acyclic graph so as to schedule them in a proper way.
For simplicity, let's assume these all tasks are independent.
Okay. Fair enough. Then okay, fine. Let's say a task is already run, right? Probably I need to have a DB to store what are all the history runs, right? And whatever is the what does it store is like a history of runs of tasks. And given a task, probably I'm leaning towards a key value store with what was the task name or the task ID, and what was the time it ran, and so on and so forth.
And how this DB will help us?
Probably if you want to look up like something like if you want to build a dashboard, or like if you want to know what exactly happened yesterday or last week,
okay,
we can go here and we can look up all the data over here. Okay. Yeah, you can something like okay. Okay, I'm just thinking what all the things.
So let's talk about the queue part, right?
Okay.
You have a task coming in a queue, and then you will probably have multiple instances of the scheduler service, right? So how would you make sure that how will your queue make sure that no two instances read the same task?
Oh, okay. So if we are if we are talking about the queue itself, let me write it here. So there are, I mean, if you think about, there are like many very good open source queuing mechanisms out there. Something like Kafka, like there is a concept of like an basically publisher and sorry, there is a concept by name like a producer, and then there are like a consumers. So n number of n number, there could be like an n producers who are like putting the things into a queue, and there could be like an m consumers who are like consuming. We can set to choose this consumer is only interested in picking up these kind of tasks. Since there are like wide variety of users, like some might be interested in only scheduling some type of jobs, right? By selecting what to read within these consumers, we can have like a separation on that to begin with.
So you're saying, just to be clear, that you will have different groups of consumers consuming different types of tasks.
Yep. Yeah.
Okay.
That is one way of
Okay. So let's say let's say you have certain A type of task which is kind of scheduled more often, or more users want to kind of schedule those kind of tasks. So will you have these cluster of consumers, different type of consumers? Like, I'm trying to understand what are we gaining from this grouping of consumers?
Oh, okay. So yeah, if some of the tasks require like a different set of use cases, right? Some may require some might be like a stream job, some might be like a batch processing job. So I want to make sure my resources and environment is set up accordingly.
Got it.
And, yeah.
Got it. Makes sense.
Okay.
Okay. Now let's say that yeah, I do not see a way where how will we tell the user if a
Okay.
job
Yeah.
failed, and where are we handling retries?
Yep. That's a good. So the scheduler service, right? Probably the scheduler service is a loop back. There should be a loop to it. What I mean here is like there should be a data logs actually. I should say something like okay. All the logs will be stored over here. Probably whatever is the thing. If you want a more detailed logs, you can go to here. It can be one more DB with key values, something like given a key, what are all my given a key that is like a task, and what are all the log that are associated with it. And even before writing it into here, I need to know whether if it is a success or failure. So probably there should be a probably thinking in terms of an API, there can be an option saying that, okay, what do you want me to do if there is a failure? Is it a retry? We can think in that direction, or to make the thing simpler, we can pass the feedback to the user, saying that, or we can have something like an alert mechanism, right? Yeah, that would be a good way, or actually a notification service which I can think. Whenever there is some kind of an either if it is passed or if it is failed, we can inform the user accordingly, and user can probably take an action on top of it. That is one way I can
So,
think.
so the scheduler service is how it's gonna tell the notification service? Is it a push or is it a pull? What kind of a
Oh, okay,
mechanism do
okay,
we have? Yeah.
okay. So how does this work, right? So as soon as scheduler is always going to push it to notification service, because scheduler service is then it knows when a job is finished, it knows when a job is abruptly ended. So that would be a right way of doing this. And as far as the notification service is concerned, and as soon as the notification service receives any kind of an input with respect to any kind of a job, probably okay, scheduler service can say something like this, right? Okay, this is the whatever the task ID, task name, and these are the logs, whatever it happened, and possibly a boolean success or failure, right? Based on this, we could possibly trigger one more API call from the scheduler, from the notification service to user actually. Does it make?
So you mean to say a callback?
Yeah, we could have asynchronized callbacks. That is easier, but I was more thinking in terms of like if there are like many devices, or there could be many things, right? It need not be a simple program, but it also can be like a notification to a mobile or laptop, email, or many things. So yeah.
Okay. Yeah, because I did not see an email in the API design. So I'm
Okay.
assuming there will be any email that a user will have to.
Oh, okay. So that is fair actually. I agree to it. Like probably we can have something like in the user DB, right? Whatever we can have like an email ID, or like whatever the preferred contact, and what also the mobile number if it is required.
Yeah, that's okay.
Okay.
So we are saying, so can you just walk me through a flow of,
Okay.
let's say I submit a job that should run every day at midnight, and it's a bash script. So how would the system behave?
Oh, okay. So that's great. Fine, let's do it. Say the user has submitted a bash script which contains like okay, so it also should contain, you said it, okay, you said it can be a single time schedule, but the schedule itself can say like run every week, and it has to run every week, right?
Yeah, every day,
Yeah, every day.
midnight.
Okay, whatever is the, probably I will have like something like an interval time over here. Okay, assuming that the user give me okay, let's say the user has given me a bash script to be run every day at midnight. First of all, I will hit my load balancer, and then get into my data ingestion service. We will get a URL, and the content of the bash itself is stored over here. And we will put the things into a queue. And when the scheduler service is hit, it will probably check the interval time duration to begin with. And it will try to create like n tasks out of it, depending on the start time and the end time, probably. Yeah. Probably we need a end time also to make sure at what, I mean, if we want to run it forever, or like maybe stop it off for a year, scheduler service should be able to
So you're gonna create tasks how many ever that the user, let's say I want to run this for 1 year every day. So you're
okay.
gonna create 365 tasks.
Okay, that's a good question. So we can do it both, right? We can do it in two ways. One thing is like we can schedule 365 jobs ahead of the time.
And where will these jobs live? Whatever you are scheduling, where will they be? They'll be on this instance of scheduler service.
Okay,
Or,
scheduler.
or on
Yeah.
that DB, like where will they
Yeah.
be?
So basically, scheduler service can, as soon as it is it receives a job. Let's go with one approach where like it will create like 365 jobs and dump it into a DB, and it itself might have its own DB, and once it dumps into the DB,
where is this DB? Can you
okay,
maybe
okay.
show? Okay.
So let's say scheduler service has some own of its own cache, right? Like
Hello.
Because it is a
Excuse me. Are you talking about repetitive tasks?
Vinil, sorry, it's a mock interview, and we
I see.
would take discussions after.
I see. Okay. Okay.
Okay, so each microservice has its own like app layer, cache layer, and the DB layer. So I'm thinking a cache layer within the scheduler service. So what it might have is like what is the task ID, and what is like a time start it needs to run. So what my API in the app layer of my scheduler service, I will go ahead and write everything into my cache when it needs to start. And probably I will pick the topmost one every time in my scheduler service. Basically, you can think it of like an one more one more queue, like where the left item is popped up, and I will keep receiving the items based
Where
on the.
will that queue be?
Yeah, scheduler service itself will have like its own inbuilt program.
Okay, so it will the queue will be on scheduler service, and it will have what?
Okay, it will have all the tasks that needs to be run in a sorted way according to the time that it needs to be run.
For if this instance goes down.
Oh, okay. That is entirely like there could be many mechanisms for it to solve the reliability problems, right? There could be, we can solve the problems either using the replication for the availability. We could take several approaches, which also something like master slave, or like we could go with peer-to-peer.
So master slave for which, what, like cache or DB? Where we are doing? I didn't get that.
Okay, so the question was, what happens if the jobs that are already sorted goes down, right? Probably I will have a I will have like a master slave approach where all the jobs that needs to be run, as soon as the scheduler service tries to commit a job which needs to be run like 10 times in the future, right? I will commit it to the master, and master will replicate everything into its slave, so that slaves can be used for as a backup. And whenever a master goes down, probably I can rely on the slaves with some sort of inconsistency, but it all depends on what we need. This is one way of doing the replication. So that is what I mean by master and slave.
So you're gonna create a master slave for service instances?
Yes. Yeah.
And only your master is gonna get the pop the requests from the queue, and
True.
no slave is gonna do it? Okay.
Slave is more for backup, and in order to maintain the. So for making it faster, I'm going with the master slave approach rather than having the more. Yeah, I mean, yeah, in this case, like a slave is more for an backup purposes, and master is more for faster writes and reads. Yeah.
How would you scale this service? You only have one master doing everything, right?
Oh, okay. So as far as reads, okay, sorry, for writing purposes, I would use master, and I would ask these slaves to be replicated. And for the reading purposes, I could rely on any one of these slaves, and as long as I can see in the slaves, I should be able to read them, and that is I am going to scale it. Yeah, thanks for that.
So master is gonna write where master is gonna write?
Master is going to write everything into the slaves. Basically, it is going to replicate, like, let's say I have like 10 tasks that needs to be done, right? I'm going to replicate that everything onto the each one of the slaves that it has.
Okay, okay. All the queues will have those 10 tasks. Okay.
Yeah.
Okay. Okay. Do you want to add anything more? I think we are on time. Yeah.
Yeah. The one thing which we getting back to the requirements, probably I need to consider about the 1K RPMs over here. Since if the QPS is going to be a bottleneck, probably then we should probably have a scalable system, which means that this should be scheduler service itself should be replicated. And okay, I'm just thinking in terms of an hotspots. Probably the API or the app layer will be an bottleneck if we are hitting many requests. So we might want to also like do a replication on the API layer and see how we can remove the data hotspots over there.
Okay. Thanks.
Yeah, thanks. Yes.
Yeah, we are done with the mock interview.
Thank you, Chavi. Thank you, Sai. This was really good. So I think the next thing is what we can do is generally we first ask the candidate to do a quick self-assessment. Then other folks can give the feedback, and then followed by Chavi, who's the actual interviewer. So, Sai, do you want to do some kind of a self-assessment, or if you don't want, that's absolutely fine. You can even pass it.
Yeah, I mean, probably a quick 30 seconds, right? Definitely, I should have read the requirement correctly. That is like one definitely a big red flag I see over here. And as far as the flow is concerned, probably it's okay, but it would be better if it was like more organized, or I would, those are like two things which I can think of right off on top of my head. Yeah.
Okay, thank you. So, other folks who want to give any feedback to Sai, and it should be just on the interview. We would do technical deep dives bit later, so it should be quick. So it should be things what he did well, things he could improve, and things he should cherish. So it should be like a very quick feedback.
I think Dippy here. Yeah, so just as a quick feedback, I think overall, even the question, first of all, question was very good. So good pick there. But also in terms of, interviewee performance, I think it's I liked in a lot of different ways. Like it was a complex question because it had so many dimensions to look at. Initially, there was a bit, confusion in, requirement clarification, I believe, but over the course of the interview, I think there were good ideas. At least I felt that he's picking up some good concepts. He's taking ideas from some, whether it's master slave, replication, scaling reads or writes. He talked about queues and consumer producer. So I think there were good, at least it was, to me, it was showing some good knowledge points. But of course, overall design, we can all it can be, any design can be revised that way. So yeah. Yeah, that's all.
Hi, this is Satyan. My feedback is there were a lot of ideas, but to me it appeared that not all of them connected very well. So I think one thing that happens is sometimes when we are preparing for these interviews, we learn these concepts, and then sometimes we want to use those concepts just because they pop into our head at some point of time. They may not be necessarily the most relevant elements to apply at that point of time.
Right.
So I think doing a better job in terms of being able to run through those exact scenarios and try to
So I
attack the
have.
core of the problem at the first, and then move on to how to solve the other challenges around it.
Yeah, definitely.
Yep.
I will have follow-up questions, but I want others to chime in. I don't want to hide.
Yeah, I had a question on the design, probably.
No,
So
all
can I?
technical design questions we will do at the end. So right now we are only doing a quick feedback to Sai on anything he can do different or things he done well for his next interview. Technical things probably we'll do once the feedback section is over.
Hi.
Yes, you can go ahead. Let me speak after that.
Okay, so it really seems a good challenging question. So thanks to the interviewer for coming up with these questions. Now, coming back to the feedback, I think the candidate did really well starting with the requirement. He discussed the non-functional requirement as well, which is good. But I think the discussion goes in many directions, and that happens because the requirement was not fixed in the first half. So I think the candidate can improve on that part, because if he does not clearly mention what the system functionality will be, then the interviewer can take this discussion in any ways, and that if that happens, then he will not be able to come up with good design. So I think this is my feedback.
Yeah, thank you. Yes, so overall, yes, actually, Manoj. So the overall thing was very good. Yeah, I think it was a very good question because it's a little complex to build a batch system. There are different type of batch system. So the one thing is, I think we could have focused on what type of batch or a scheduled job we are going to build, like for audio encoding or decoding, very specific, because batches are very complex to build. So it could be on a specific thing, so it becomes very clear. And yeah, apart from that, yeah, the overall and the intro and the intro both are, yeah, good. So one thing is, yeah, he came up with the design. The design was very good because to build a batch system is complex. So
Yeah,
think
I
and
think.
do this, right?
Yeah, I think in general, there, like we all are saying, right, there were so many dimensions to this problem that to me, it's more like, okay, if I was given this question, how could I have, like, boxed the scope of it to make it clear? Because it becomes a hard question, at some point.
Yeah, so it was very good actually.
Yeah.
Take it up and do it. A batch processing is very difficult. Yeah, it was very good.
One feedback. I didn't see like some numbers usually people write about how much data is need to be stored. Those scalability numbers usually is part of the design. Sometimes they are not. It depends on system. This one does not have it. That's one. And the other is at the end of the system design, usually candidates also talk about a little bit about testing and monitoring. I think that would also help.
Okay, thank you.
Okay, any other feedback to Sai from anyone?
Yeah, this is Satyan again. So one more piece of feedback is that a lot of the times what happened was the interview was requiring to probe certain different dimensions, like ask what will happen in case of a retry, how will you scale the system. So some of these things should be addressed right away at the beginning itself. Not in the detail, but at least have clouds about them. Like we are going to talk about retries. Have some of these considerations early on at the top level itself. And then if needed, then deep dive into one of those if the interviewer asks. But I think some of those aspects were missed in the design in the early stage itself. And then it's easier to go deep into one dimension and then miss some of these critical components.
Okay, thank you, man.
Awesome. Anyone else?
Hi, as a follow-up to the same point of missing out requirements, like I just wanted to give this feedback. When we write the functional requirements, like if we write it as proper bullets, like every unique requirement, like for example, he wrote like ability to start and stop the job and schedule it for the future. And after the interview is done, or most of the interview is done, it's always good practice to come back to the functional requirements and map it to the components in the design to ensure that have I covered all the requirements put forward. That's something I figured out in multiple mocks and interviews as such. Overall, it was very interesting topic.
Yeah, thanks, Venkat.
Anyone else? Okay, then, oh, somebody speaking. Suchi, we can't hear you. Suchi? Okay, so I think these are really good feedback, and Sai, I would say like I also tell everyone like there would be a lot of things, and system design is not something we can go with some workflow. It could go in any dimensions, in any direction. So whatever feedback you're getting, just take in that way what makes best sense to you. And if you think like something is not appropriate, even you can skip that. Even I do with me. So with this, I would like to have then Chavi to give feedback to Sai.
Yeah, Sai, you did really well, I guess, on a lot of things. First thing, I like that you were able to create different microservices, which is like creating separate components, following the single responsibility principle. So I did not have to worry about, okay, if this goes down, everything goes down kind of a scenario. The other thing I liked was that you were taking cues that I was trying to give you, and you were trying to incorporate them in the solution. So thumbs up on that. So there are certain things I felt if they would have been done, would have probably have made things easier. First, as you realized as well that the requirement wasn't clarified in the start. I kind of tried to, tell you the requirement like 3-4 times, and I felt like you were coming back to that user will somehow know what task he wants to schedule, right? So that was one thing that an interviewer might not like, that a person has to tell again and again what we are trying to build here. The other thing that I felt could have been done better was the going back to the requirements and mapping if the system was doing everything. Like, for example, you asked what is the average time of the task, and I said 1 hour. We did not make use of that data information in any way in the system, right? So that probably could have, we would have gotten back at certain point to see whether we are making use of all the information that is provided to me, because that information is provided for some reason, because the interviewer wants you to do something with it, right? And here it was for the reason that when would you say that, okay, if a job is say running for 24 hours, right? And we know that average time is 1 hour. Do you want to not kill it? You probably would. Otherwise, it probably is running into infinite loop and, churning all the resources. The other thing that was not very clear to me, that why you opted for a master slave on scheduler service, right? Because that is a service that you would want to scale, right? And when we say master, that means you have one instance doing all of the work. And we know even with the Kubernetes kind of architecture, the pods keep on spinning up and down, right? So every time you would have this leader election, if you have this master slave very so often,
Yep.
right? So that I felt was not a good way to would scale this service or handle. The queue should probably would have been outside this service.
Okay.
So yeah, I mean, that's like one idea that I could think of. Yeah, and I really like that you were able to think about monitoring, creating a dashboard. The other thing was that when we talked about how would a user would know if a job is fail or not, we had to like go back and add things to the API. So
Yeah.
my kind of feedback is maybe this had to be thought before, right? As a user, if you do something, you need a response back from the system, right?
Yep.
And the other thing from the notification service, yeah, I think that's all good. I wasn't clear on a certain things when you said M consumers. Were these consumers the scheduler service instances? So all of this was not very clear when you were explaining things. And again, I told about retries. I mentioned to you, and then I think it got lost in the conversation of how we are making use of these retries, how many times you're going to retry if a job fails.
Yep.
Right? How you're going to keep that count. I do not see anywhere in the DB schema that we are keeping that count of retries.
Yep.
Yeah. So yeah. I mean, again, there are a lot of things you did really, really well. Keep it up with them. And just my 2-3 things, if you can, I think keep in mind, it will probably help you do better. Yeah.
Yep. Thanks, Shavi. I really appreciate you doing this.
Okay, awesome.
Hello.
Yeah, Vinay.
Yeah, a quick question. Like for this question, right? What would be expected of a principal level candidate versus a senior level candidate versus a junior?
Okay, Vinay, we need to hold on. Right now we are only in the feedback section. So we need to hold on any questions on design or any alternate to that.
Sure.
Yeah, just wait for a few more minutes. Okay, so
so this is Deep.
Mhm.
Sorry, I had to actually disconnect the call sometime, but maybe like this feedback has already been given. But I found that the candidate very well. Few things regarding like non-functional aspect of the requirements was not fully covered, as I think. There was some assumption already in the candidate's mind about what task is. That actually should be like included. It's a feedback that non-functional aspect of the, actually it's a functional aspect of the not the non-functional aspect of the problem, but regarding not the scale, but just what the task is, what the scheduler should do. That thing should be more clarified. And the second part of feedback is that exception handling should automatically come. Like anyone should actually have a separate time allocated just for talking about the exception handling. That part, if the interviewee includes in their next discussion, that will be very useful for them.
Thanks, Deep.
Awesome. So yeah, so I think Sai, if I would say that it looks like people gave on the how the requirements are captured. So I would say SD Skills is a platform where you practice. So in that way, you got some good tips today. So you can use it in your real interview. And for anybody, use SD Skills as a platform to test yourself. How comfortable are you with these tools? Doing these for the first time, I think everybody struggle. In that way, you did a fantastic job, and anybody else also can use SD Skills as a platform to fail but to fail forward. And but I'm not saying you failed today, but I'm just saying like if there is some improvements, use this platform to try it out.
Yep.
And with this, anybody wants to give feedback on to the interviewer also?
Yeah, probably I would jump in.
Okay.
Yeah, first to begin with, thanks. Really appreciate Chevi, and I mean, so if you look at a real interview, that is how you really guide a user if he is either going in a right direction or wrong direction. So I really liked it, and yeah, I can't think of anything negative, but probably I mean, I felt like since this is like a 45-minute interview, it was a little bit scoped in a broader way, which is perfectly fine. So, and that me towards here, and definitely I'm very bad at doing that. So I learned it. But yeah, overall, you really guided the candidate very well whenever I'm going wrong, and also you know what aspects you want me to drive, so that is also really good part. And yeah, that's it. Thanks for that.
Cool. Anyone else wants to give feedback to interviewer?
Ramesh here. I just wanted to say the interviewer was excellent in guiding the interviewee, like he mentioned himself. And I like the clear approach, the clear thought process of digging enough into each new components the interviewee was bringing it up. One good thing about the interview as well is was he was taking the questions and directly responding and changing his designs as he went. So overall, the flow itself was the interviewer was able to get the flow perfectly right at the right level of depth and right information from each of the components, digging through the technical expertise of the interviewee, how good it is he is at the concepts that he's bringing it up. So right level of program, excellent way of closing it out. Thank you so much.
Okay. Anyone else?
So one piece of feedback, I'm not sure if this is feedback, is just a comment, I believe, because I missed the very early part of the conversation. And I don't know what the experience level of the candidate was. And in that context, so the way we pose a question in the beginning would be different for the same problem, would be different for different levels of interview skills. Sorry, different level of candidate skills. So for a young candidate with not so much experience, you would expect the problem statement to be a bit more detailed and a bit of more information laid out right out in the beginning. And for a more senior candidate, you would expect the candidate to be able to dig through the problem and I don't know if that was done, but because in the early stages, I felt there was some miscommunication. I don't know where to attribute that because I was not um, present at the early stage. So maybe some comments on that would help.
Okay.
Yeah, just to, I think this is Deepi here again, but I think everybody, sorry, I had to step away for a bit, but we are talking about feedback back to Chavi, right?
Right.
Yeah, not sure if it's covered already, but I think it was an excellent question. It was different from the typical, the 10-12 questions that keep getting circulated. So, and it really helps to think aloud, different ideas. The only thing I was, I don't know if how accurate is this, but is there a way that the problem can be scoped a bit better, because they're so broad question. But again, I don't know, like if it is how it depends on the interview, right? And I don't even know, like somebody was just a minute ago mentioning about different levels of interviews, how the question is scoped. So that might happen. But in general, over towards the end of the interview, I was actually talking in my mind that, okay, this is really, there's so many dimensions one can take. And the other thing I have in mind is along the same lines, and it's a bit of a question to everybody, that how does, is it subjective that in a question like this, does the interviewer wants to get at least one microservice working end to end, or is it like they want to see a broader picture? I don't know if it's subjective, or is this something that can be, there is a protocol or sort of a best known method that people go with. But as an interviewee, if I was an interview, if I was a candidate, yeah, I mean, I just felt that was a very broad question. Yeah.
Awesome. And let's circle back on this, DP, on your question.
Yeah.
That is a good discussion. So
but thanks, Chavi, and thanks, Sai. It was amazing.
Yeah. So with this, I would like to wrap up the feedback section. I think people give really candid feedback to both Chavi and Sai. Would be helpful for both of them in their future endeavors. So with this, I think now we can move until somebody else wants to share any feedback. I think I can go with count of three. 3, 2, 1. Okay.
Yeah, should we stop the recording as well?
It depends. Sometimes we capture the tech discussion in the recording.
Just want to make sure.
Okay. I also posted this link in the chat where we discussed the job schedule, like a deep dive a while ago. It could give you some pointers different than what discussed today. But with this, folks can now deep dive. I think Vinil has a question. DP has one question. So with that, I think we can talk about some deep dive thing. And I need to step out. So Chavi, at any point, if you're around, just feel free to stop the recording when you think like we covered some good aspects.
Sure.
A small thing, if anyone is sharing the links, can you share it in the Discord, because the Zoom chat vanishes after the meeting, so we can't get it. Yeah.
Yeah, I think DP, sorry, Vinil, I do not remember your question. You can please reiterate, but DP, for your question about how broad. So I have gotten interview questions just saying, okay, design a notification service, right? And that's it. That was the question. And it was my responsibility to scope it down or up. And I feel anywhere from senior and staff roles, this is what is the expectation. And I did confirm with Sai about his experience and what he does for work. And it's definitely better that if we are interviewing a candidate who doesn't do it as part of their work, probably should have more scoped out details already. But yeah, from what Sai told me, I felt this is like valid for him to.
No, I think actually that totally makes sense. Maybe putting it other way around. You mentioned this spot on that you're given a very high level description. And I think not just necessarily senior roles, as I'm thinking about it, even if it's like SD2 or something, it can start very, high level. And then as a candidate, how can we just narrow it down? Maybe going back to, if I was mentioning in my chat that if as a candidate, if we can compartmentalize it. Yeah.
I'm just telling you what was my rationale behind going a very generic, like a question, let's design this system, and then we can probably, even in a real world.
Actually, Chavi, I think my question was a little different. It wasn't about description, like when you start with, that's a high level, right? But as we are going through the interview, let's say candidate is going in different directions, right? Like you're picking one aspect and stuff. So as an interviewer, is there a standard paradigm in mind that, okay, in this problem, I have these 4 microservices and I want the candidate to, at the end, ideally finish one microservice, complete A to Z, right? As an example, have a clean design. Or is it more like if the candidate is jumping from A to C, and now while designing C, there are questions coming up, right? So you as an interviewer would come up with those questions that, okay, how would you handle this and that? And at the end of it, none of the microservices as such is complete, but and I'm
I
not.
think,
Yeah,
I think that,
I have very quick
okay.
2-3 minutes. I can quickly give my perspective on that. So DP, I feel like this is very subjective to the interviewer who is taking
Yeah,
the interview. It
yeah,
could completely change. There is no, I would not say there is a written workflow which anybody can follow. It's
okay,
really, really subjective. If I am the interviewer, I would try to nudge the strengths of the candidate. So if
yeah,
I feel candidate is strong in some area, I would not try to impose my agenda on the candidate. I would try to.
that is a lot. Yeah, that
So I
makes a
would
lot
try
of
to get
sense.
more out of candidate as a data point. So if I feel my data points are covered, that's what many
Yeah,
interviewers does. So they very seasonal interviewers before the interview itself, and I feel like it's a very candid approach. Before the interviewer itself, before starting the interview, they say that, hey, when I will ask you to hop onto some other component, don't feel bad. That means like I have covered all the data points and I want to go into different area. So that doesn't
right.
mean you are not doing well. That means
Okay,
like
sure.
I'm good with what you have already said.
Awesome. No, that makes sense. Yeah. I mean, it wasn't so much of a, question as such about the how Chavi you approached it, but it was just taking an example. But yeah, this that answers my question.
And if there are I always feel like if you break into microservices, small components, it's easy for the interviewer to understand what you are thinking. There could not be all the components which interviewer would be interested. For example,
Yeah.
writing submitting a new job, it is just
Mhm.
one part of component. Interviewer might not be interested how it will scale or other things,
Of course. Yeah.
because the meat in this problem could be the scheduler. But
Schedule.
interviewers know how to submit, how to update the job, how
Of
to
course.
keep
Yeah.
the settings, and then it doesn't represent the single point failure. So if one thing goes down, it should not bring the entire system down.
Sure.
And distributed systems, like they should be micro components, scalable, horizontally. So yeah.
Right. No, thank you.
Hey,
So I have one question I have. So let's say Q was trying to submit a job and this scheduler service went down, right? So, and if this is a Kafka, then Kafka, I think, has the ability to send the job again, same job again, like as long as it is not finished. So let's say he tries to send the job again, and by that time the scheduler service comes up, right? So will that, I mean, that job will be duplicitous, right? So how would you deal with that? Like, is it allowed to, I mean, pass the same job again and again? Like, how do we preserve that
So I think
duplicacy?
that's a question that we
prevent it?
need to ask, that whether the jobs are idempotent or not. If the jobs are not idempotent, like for example, if they are sending SMSs, or they are kind of maybe are jobs that gonna call a different service or change their DB or something like that, right? Then we have to make sure we handle this duplication of tasks running. If they are idempotent, then doesn't matter if they run more than once, it's not gonna. So for example, it's a cleanup bash script, right? I say clean up any records which are more than 24 hours old. So even if my script runs again, so I will only say, okay, I mean, that's probably not a good example, because so it will be probably, I'm assuming here that the task that would rerun again, which is a duplicate task, would be in minutes. Okay. So task one ran at T1 time, and then this T2 time, which is T2, is probably less than 2 or 3 minutes difference. So if that is the case, it should be okay, right? If you're cleaning up my data for 3 more minutes, that's fine, right?
You'll have some sort of TTL kind of, yeah.
Yeah, right. But if the tasks are not idempotent, then this needs to be handled. And this is a question probably we can kind of ask the interviewer to clarify if we need to handle this.
But
Okay, and go ahead.
my thought is this is not the job of the task scheduler to make the jobs idempotent. Whoever submits the task, that
No,
person,
we are not making idempotent tasks. We are asking if the tasks are idempotent or not.
yeah, I agree with that. My thought is we shouldn't be bothered whether the tasks are idempotent or not. Like, why would the task scheduler worry if the tasks are idempotent?
So
Whoever.
because if we retry a task that is sending out emails, for example, right?
Okay.
And if we rerun that task again, so there will be duplicate emails being sent to your users.
That is correct, and that is a different responsibility on a different system to check whether the emails have been sent previously before sending it. The task scheduler, in my opinion, is responsible for scheduling. Like,
No, that's completely acceptable, and this can be your solution to, like, my task scheduler will not take care of this.
Sure, that is my opinion. Yeah, sorry, Shashank, if you have go ahead. Other question, otherwise I have some question.
One last question.
On the same, I have a comment on that. So maybe one design here is that the scheduler doesn't need to know if it is idempotent. It just needs to be able to accept a retry strategy, and that is finally up to the end user to choose what they want to do in case of a retry, because that will vary from a job to job. So I think it's a better approach to just expose that as an option, as a parameter on what different retry strategies are possible.
Right, retrieval strategy and idempotency are two different. Retrieval strategy only tells you like how long I have to wait before I can retry. Is it retriable or not, or should I just attempt best case attempt and then leave it? Those are different.
So basically, the user is responsible for knowing that if this job runs again within 3 minutes, and if it was successful, am I harmed or not?
That is correct.
For example, build twice or not. So it's up to the nature of the job, and it's for the user to be able to decide, not for the scheduler to decide.
Exactly. That's my point, that the scheduler should not be responsible for keeping idempotency check. It should be responsible for whether I have able to complete this task or not. The end task or the what task does, that's the responsibility of the person who writes the task to check whether if this task runs multiple times, would it be a idempotent task, or would this trigger like multiple SMSs being sent? That is, in my opinion. I could be wrong.
Hello.
Yeah.
Just another thought. Like I think another question could be for the same problem, like thinking about resource requirements. I'm not sure if that was discussed. Like each job, how much CPU or like how much RAM or disk space will be needed, and and the environment needed for the job to run, like where will it run, like to provide the environment, like should we download a Docker image and run it?
That can be a part of the query that a user submits to give all these environment configurations to the scheduler, right? So that as Sai also mentioned, that he will have different consumers, like different instances running different kinds of tasks. So if the picked up task is, say, let's a bash script, it will have a different instance. If it's like Java program, it will have a different. So all of this can be a part of the configuration supplied by the user, right? And for the resource handling, that's a good question, because I am not sure before running a task, like if we have some historic data about a task, that can be handled. But if I'm running the task for the very first time, I don't know how long does this take.
No, even before you design the program, you would know, right, how much how much RAM it would need, and when you are designing it, you would know, like when you design a batch job, you would know like its resources. You can
Sorry, go ahead.
Sorry,
Go ahead.
Sorry. Okay. No, I was saying that it's not like after you run, you would know it. it's like before you even design your job to run, we would do like the estimate of the resource.
Yeah, and also like estimation, right? We may not even need, it depends, right? That's a question. That's a good question to pose, because I'm thinking from, I was having this discussion on the side that let's say you have the system with, I don't know, 16 cores, and right now there are multiple jobs running on it, and right now you see 4 cores idle, and you just launch your job. If it finishes in 1 hour, whatever its limit is, fine. Otherwise you handle it next step, right? What you need to do with incomplete jobs or whatever. But yeah, I think resource management was another topic I had in mind, that have we thought about dependencies between tasks, which I think, Chavi, you mentioned that we don't need to take care of, at least in this problem. That was fine. But what if there are dependencies with respect to resources? Like I need some, core usage, right? Whether it's coming from my estimation or whether I just need some cores to run and everything is busy, then
We
I
scale. We scale, right?
Yeah, but
What is
who does
No,
that management of scaling?
no, not just management of scale, right? There are scenarios where you have, like, depending on how many jobs you have, uh, as a general question, not talking about specific situation where you'll run into this, but uh, is the thing about dependencies coming between task and resources, right? If my task is reading something from memory and my CPU is stalled, I don't want that then. So I was thinking about something going into data structures wise, like, do I need to handle something like topological sorting to arrange my tasks? I don't know, just a very high level thought, but is this even?
But when you say arrange your task, you mean in the queue?
In the queue, in the wait queue, I would say, right? Not like, because every task has a time to run, right? You said that I want to run a task at 8 a.m. So I can't just arrange it to run at 9 a.m., right? That's not there. But any task which is in the, I was thinking from the OS scheduler point of view, we have different queues, right? Wait queue, runnable queue, running queue, right? So any task which is in the wait queue, right, or runnable queue, how do we order them, right? I have 4 tasks which are waiting to be scheduled. And let's say all 4 of them, users submitted that, 4 different users submitted 4 tasks, and all of them are supposed to run at, they mentioned 8 a.m. as the, task time. Then somewhere there is a, it's like a concurrency sort of thing, right? All of them are listed
So
at
when
the
we're
same.
talking about OS, we're talking about one machine, right?
I'm talking about one machine there, but it can be, I'm thinking is that problem can be even happen in distributed system. Like, I don't.
So I from how I see is that if I'm able to scale, I
Yeah.
do not have to do this. Like if 8
Worry
tasks, if 4 tasks have to start at 8 a.m., I'll just start them parallelly on 4 different instances.
I see.
Right.
Okay.
And if for example, if the interviewer says that, oh, I want to optimize, right? Cost is a problem for me.
Yeah.
Then you would have to think that, okay, if I have enough memory and CPU available to run 2 tasks on a machine,
right?
Then somewhere you need to maybe have a data that how much of unused CPU or cores you have available for every instance, and where you can schedule. So you will have another algorithm that will match your instances to jobs.
Right. Priority defining that. Yeah, makes sense. Okay.
So we have various. Hi, Rupi, I have a question actually. So why do even I have to check the priority of task? Because the scheduler's job is to run the task on that specific time, right? So why do we have to care for priority?
No, it's not the running. Scheduler job is not to run. That's the task executor, right? That's a different component in view. But scheduler would be like, I am given, the way I'm looking at this, there is a component. The input to scheduler is a list of tasks that are coming from different clients, right? I have 10 tasks coming and I have a set of resources which are scalable, right? How do I, and I have a set of requirements that I have to schedule X task at certain time. And then how do I just allocate them that, okay, this task goes to this machine or stuff like that. But correct me if I'm wrong in that assumption. Because scheduler is more like assigner, right? Like you are assigning tasks to.
Also adding to that, so scheduler needs to store in such a way that you can retrieve all the tasks to be run at this time, right? So that also is part of scheduler. Right? I think was that scope of the problem? Store it in such a way that it's optimally designed to get the task to be run at the next minute or something. So that is also scheduler's job. So,
so scheduler, right? It would know to which node it needs to schedule. If not, it's not going to work. The scheduler has to do all the metadata information to the job. If not, it's not going to, because the worker, right? The worker is the one which is going to pick from the queue and start processing.
So worker will need to know that which task to pick, right? There will be thousands of millions of tasks. So how will it know that at this moment I have to pick this task? It needs to be stored in such a way, right? That you index on time or something.
I think that's a lot to do for scheduler. Scheduler will just ingest the the request from the user and will just put it in the queue and say this needs to be run. Right? This is the next. So you can have an algorithm like a different service, which probably takes or maybe scheduler service can put that in the DB. And there can be another service which kind of has this algorithm which says, okay, what is the next most recent task that needs to be run? And we can put them in the queue. Let's say the next 10 or 20 tasks.
So the other point is that you're not going to have a single queue in a distributed system. You're going to have different queues for
but queues can be rebuilt. If say
the scheduler, scheduler would push all that to different queues based on that how it is going to schedule it. So it's not the worker is going to look into each and every message that is coming where I need to run this. It's because the scheduler is the main part which would decide all the metadata information. The worker is just going to pick and start working on that.
Are we executing all the jobs under same machine?
No, it would not work.
So if we have a queue like SQS, right? That different services can just put tasks in that SQS, and that SQS can be accessed by different instances.
Right.
I had a question on how the scheduler polls for the next tasks to be scheduled. Is it like running every second? What is that granularity before it polls?
No, schedulers, right? See, I have built a batch system, a general batch system. So in my previous company, so building a batch system, right? You can have different triggering points, like looking for a polling, looking for a request, looking for a DB trigger, looking for an event to happen. So based on that, then you can have a cron-based job. So all these are events. Batch jobs we built around 15 different events. I don't remember now all this, but these are some of the components that I directly work. So whenever there is a file placed in a particular location, the job will start trigger, and it would go and get placed into the execution mode, and the scheduler will pick it up and then start scheduling the job. Once it puts into the queue, then the worker, right, would take that, and it will have different queues. Okay, the scheduler itself will decide where to put the message, and the other side of it, the worker will pick the job and start processing. So in the worker side, there can be jobs which can get hung. All these can happen because if it is so there are within that job itself, there are multiple steps. Okay, so one is the read step, one is the process step, and the write step. And so there are within that you can have parallel steps running within it. So all these can be done. So it's actually very complex when you start going into the job, how actually it is built.
Can I ask a follow-up? Yeah. Like I did not understand when you said there are different ways to do this. There are different ways. I am asking, like when you said one of them was event-based. Are these events? Can these events be lost? What happens if one of these events get delayed and my task, which is supposed to run at 8, ran at 8:05 because the events got delayed. Oh, so what happens if the events got dropped? Is it like always the events will be captured? If events were not the case, you said cron job. Are these cron job running at a particular interval, like 1 second, 1 hour, or whatever is that interval that you guys decide? That does not matter. But who monitors that cron job? What happens if that cron job does not run? I have those questions because I have faced similar issue. I fix it by like a database job which polls every X minutes, and I have a monitoring system that monitors that cron job and alerts on call if there is some issue on that cron job. That is one of the way that I have fixed this issue. Can you elaborate a little bit more, please?
Yeah, so even if the event, see, on an event based, right, you're from a batch point of view, you're looking for some event and it comes late, and it is the responsibility of the sending application, which is sending the event, right? It's the responsibility of that application to make sure that it sends on the right time. Because this batch job cannot do anything until it will just look for something.
But
for
even
that,
fire and forget, right? Events are not like you won't accept an acknowledgement from an event. It's fire and forget. So if the event gets lost, it's lost. Nobody's like retrying the events again and again to check whether the event is acknowledged or not. Events are just like fire and forget.
Yeah, so that's what. So that cannot, because until the say that I at 8 o'clock there is a file which needs to be placed at that location, and if it does not reach us, then if it is lost, then it's the responsibility of that application also to make sure that this job is getting fired. So it is, so you need a separate support team to handle that. So that is how most of the companies are doing, which are using the product. And so you have no other option, because if the event is lost, then it may be because of network or something. Then how do you know whether actually the sending application has sent it, or did it
So then it's
receive?
not a
You
event,
have no idea, right?
So it's a queue, right? Like it's not an event. Like you just put it into publish into a queue, and then you acknowledge when the other guy acknowledges that I have consumed from the queue. I thought like you were just sending out an event and somebody's like getting that event through some HTTP endpoint or some other endpoint, and then you are acknowledging back with another event. Now this the other event, if it does not acknowledge, like it's are you, when you say event based, it's like a queue is what you're trying, or
yeah, I'm telling queue based. So even there can be web based requests that we yeah. So whenever there is a request which comes in, then the batch gets triggered. Then we once we research, we send out a notification that we have received. We send an acknowledgement for that. So if the message is lost, we never ran into such issues, but request losing in the middle, then
sorry
sure,
to
because
interrupt.
that's very difficult, right? It's because it's again your job got triggered off and your response got lost, then the other system would not know that the actually message got triggered off.
right? Which is why I'm thinking it's not an event. What
Yeah.
you're
So the other point is that what we did is, one thing what we did is, if the request comes back again, if it is the same parameter and information, then we don't trigger it. That's what we do.
Just a second. Sorry to interrupt you guys. Is it related to task scheduler? Because I think this is very specific to the application which you are implementing. I think you're talking about the task execution, not the task scheduler.
No,
and I don't think so. This is a task scheduler, right?
Sorry, Amit, sir, Sumit, I'm sorry about that name confused. I am telling, like, how would the task scheduler know what is the next task to be executed? One way that earlier Manoj was telling is by sending an event saying that I've got a task that needs to be executed at X minute. Another way I was suggesting is to look at the DB to find out the next tasks. And this is like a poll thing, which polls the DB to find out, hey, give me the next task. that needs to be executed. That is what I was trying to say.
Okay, so yeah, that depends on the type of a frequency you are setting.
Yeah.
If you have this specific application and you say that my frequency will be X minute, which means my accuracy of this task is going to be 1 minute, which means you have the one thread who pulls the database for every 1 minute. But what if the task can be scheduled, let's say every 30 seconds, or there are like seconds granularity as well. So in those scenarios, you probably will not go for the DB because task can be scheduled on any second or any minute or whatever, right? So you probably need a type of a system which basically inject the task into some sort of a store, which gives you continuous streaming. It's more of a streaming sort of a system, right? Where I have these many tasks needs to be executed. Probably the queue is one of the right approach.
Who puts into the queue is my question. Who puts it into the queue?
This will be the separate component. I mean, yeah, so this is a component which basically looks about all the, let's assume the cron job is our the way to define how the task will be generated and all, right? So that component will basically look through that. Okay, I think it's again depends on whether it is looking at every second second it sees that what are the tasks needs to be generated.
That is correct. And what I'm trying to say is that component that you said, to which looks for at every second or whatever time interval, is basically polling the database for every second to look for any other jobs. And why not just do that in the first place? Why look for a component which polls every second, looks for a task, put it into a queue, and then another systems looks it from the queue and takes it and put it into another worker. Like those are
the problem with that approach is, if let's assume that you pulse and you, I mean, that another way is that you can say that, okay, for next 1 minute, I'll generate all the tasks. What if somebody disable that, saying that, okay, I don't want now this task to be generated. Now, how would your system, the next application will know whether I need to execute or not? I mean, definitely there could be some rechecks can happen. Okay, now this task is needed or not. So the way interviewer also said, right, I'll generate upfront all these tasks. Probably that can go into that model that it can create a lot of trouble if tasks are every seconds or not.
Yeah,
isn't
exactly.
it that what it is? Yeah.
Those are two different things. If the tasks are like, I want to run it every millisecond or every 1 second, there will be too many number of tasks. And if I want to run this task like for a year, and I have every second task being generated for a year in advance, I don't know how that would scale. Maybe it would. The other thing that you mentioned, that to look for the tasks, that is exactly polling the database. That's looking for new tasks. For if somebody tells that I executed this task now and don't execute it anymore, the next poll would see that this execution has a status of like false, and then won't execute it at all. Instead of pulling everything in 1 minute and putting it into some structure queue, for example, and if somebody at that point tells that I don't want to execute anymore, whatever was in the queue will be executed despite you telling not to execute.
Yeah, to pitch in here,
that
like
could be
we
one
have
of the. Okay, go ahead.
Sorry. So to pitch in here, like we have a system which is in the production, which argan oil, I don't know name, he was suggesting actually. So in our production systems, we did write to the DB, and then we were pulling it. You can refer it as something like Maxwell jobs, probably, if you want to search it. But yeah, I mean, but all these real good discussions.
So
But in the interest of time, I have a question to Chevy. Yeah, is that okay to ask?
To me?
Yeah.
Yeah, sure.
Yeah, okay. So like the question I wanted to ask is like regarding the input, right? Like what should be the input from about the API, right? What are all the like things that we need to take it from the user? I mean, I agree that there need not be a right answer or wrong answer, but what could be a better way of handling it? Like task name, task ID, I was like very...
Yeah. So I felt like whenever someone a user schedules a task, right? The system would, before putting it in the DB, the system would generate the task ID for you. So now you can either send that task ID that you generated in response so that the user can suspend that task if they ever need to. So they have that task ID to use in your suspend job API, right? Or you can, I mean, that was one way. If we think about that we need to suspend jobs in the future or delete jobs, if that's not the scenario, then we can just say when the user schedule a job, we'll just say 200 okay. And obviously we also need email for a user to tell the user whether it's failed or not. Right? So that idea, I took it from the cron jobs, right? Cron jobs have this mail to attribute.
Okay.
For a user, so, right? And and the granularity of a cron job is a minute. So you cannot schedule a cron job to run every second, because that's not, you cannot configure that. So this is something you can probably, put in an assumption in your system that is the least granularity my system is going to support. You cannot schedule a task every second, or most you can do is every minute, right? And every minute the cron tab file is kind of pulled and like kind of parsed, and it sees what all tasks needs to be run. Right? So this is how cron works. So I kind of read, and I would take some idea. If I need to design a system, I would take some ideas from cron, how it does it for scheduling. But cron is like fire and forget, right? It doesn't retry things. So for currently the job I kind of configured, it runs every hour. It's a cleanup job. So it doesn't matter to me if 1 hour it failed, and the next hour it will probably run. But if I get these emails that it has failed for last 5 hours, then I go and check the logs, what is happening.
Okay.
Shavi, I think that the application which you talked about, like, cleaning up, that's a very specific implementation of this, the task scheduler. What if let's assume that per minute, and that's data is also muted, then how you basically handling the generation of those events? And I basically submit, let's say, thousands of users are generating the cron expressions. How your system is able to generate those events? What is the mechanism you are using? And if you have some thoughts in the mind.
Okay, so I from what I understand is my whenever a user would schedule, like send me a job that needs to happen in the future, sometime in the future, right? Let's say a minute in the future at the least, right? So I will push all of these to my database, that my scheduler service will have a persistence, that it will write to the database, and every minute I'm gonna poll that give me the jobs that I need to run for the next 1 hour, or next 30 minutes, whatever, and I'll put them in a queue. So if my instance goes down, that queue instance goes down, then I can recreate that queue from my query, from the database. So that makes it fault tolerant.
So, but if the DB goes down, then how will you
DB goes down? Okay, so if my DB goes down, again I will have like a replication on my DB as well, right?
So that won't have a latency in that case?
Latency.
Like till that time, I mean, that scheduler
So
will
I
wait.
will, okay, so I will have certain amount of jobs, let's say 30 minutes in my queue already, right?
Okay.
And my DB went down. So I have 30 minutes for my next master election to be done. And I feel that is enough time for, and if that's not happening, then it's another problem.
So what happens if those, somebody cancel or suspend the jobs, like, for 30 minutes you've already generated. So those 30 jobs are in your queue or database, wherever it is. How do you make sure that those are not delivered? Or are you saying that those will be delivered irrespective of whether you suspend or not?
Yes, so that is again how you tell your user can use your system. You say if your user says, okay, I user schedule a job for every Monday 8 a.m. and on, let's say, on Monday morning at 7, they said, okay, stop this job, do not run it, right? So either you kind of have another API that will tell the user that, okay, this job is scheduled to be run less than an hour, right? So you need to use this API to delete it from the queue, or this cancel or change in the scheduling will take place after the next run. So you have to set the expectations right with the user. Like how can they use your system?
Okay.
Two other ideas. You could always have some Redis which keeps tracks of whether I should run or not. Whatever jobs that you're put into the queue, let's say you put like 1 hour job, before execution looks at the Redis to see whether the status is still yes, run. If somebody behind the scenes says that do not run the job while the job was still enqueued in the queue, it would just update the Redis saying that do not run this job. And as the jobs pops out from the queue, you could always poll and look at Redis to say, is this still stated? Yes, that's one. And the second one was, instead of generating these scripts, which is like, if I want to do 1 hour job and have 1 minute frequency, then instead of creating 60 jobs per se, another way approach is you run the job once, like the job scheduler runs the job once. As it runs, it re-enqueues the same job for another 1 minute, so that if once the job completes, it looks for the next job, sees that there is already an enqueued job, it picks up the job again. As it picks up, it looks at the schedule, and it says 1 minute, again re-enqueue the same job again. So this separates the task scheduling from the task execution. These are two separate things.
So you're saying in the second approach that we are going to keep on putting it back to the queue until the time doesn't come for it to run?
So there are two things. One is in the design that was described in the interview, there was only one table which says task. Okay. What I'm trying to say is separate that into two different parts. One is a task schedule and one is a task execution. The task schedule tells you the metadata about what and when the task should be run. Should be run 1 minute, 1 second, 1 hour, whatever. Each time you pull a task from the task schedule, put it into another table called task execution, and that tells you when was the last run, how many times error for each run, success for each run, whatever. When you pull the task from the task DB or table, look at the task schedule and see when is my next run. Well, whether it is 1 minute, then put it back into the tasks table so that it re-enqueues for the next run, so that it's just ready for the next run to be run. If somebody tells, like, sorry, go ahead.
No, I think that this idea I like, because you are look ahead for the only one task, and if that, because that will not overload your system also, because you are just generating one task ahead, and when it comes, you will again generate one task ahead. So that's way it will just always have the single task in the system.
No,
right?
I have one question. Like if you, for example, if the task next run is after a month, would you still put it in the queue?
No, you would not put it into the queue, but you would say that in the next time when it runs, look at the next schedule, whether it is because already there is a job that you mentioned which will poll every 1 minute to say what is my next task to be run. If it is a task to be run in the next minute, only then it will put, otherwise it will not.
No, but that seems repetitive, because if I am polling for every minute, I already know which task I need to put in the queue. Why is this extra logic and extra DB of for execution? I didn't get that.
I have one suggestion here. So some of these problems are similar to what Kubernetes job scheduler was also trying to solve, right? So, I mean, one idea is probably the stuff that we put into queue. It's not actually the full job. It's just it would just be a reference to the job in the database, right? So whenever we make any mutations on the job, like updates or deletes, we update it in the DB. In the queue, we only put that there is some change to this object. So go and check what it is, right? So the task executor, so then it would see, okay, there is some change, there's an event, right? This is some change to this job. So when it so let's say its job is to execute the task, right? So then it will go and actually try to fetch from the DB, and it will observe that it's not at all there because the user has deleted, let's say, in between. It won't even get started. So does that make sense, or with
Yeah,
what
yeah,
we
yeah,
are
yeah, it
trying
makes
to solve?
sense. How are we? How I think your voice was a little faint for me. How are we trying to get if there was a change? How are we monitoring that?
Okay, so in Kubernetes, what they do is, so whenever we update the object, right, in the database, so the request comes to API server, Kubernetes API server, and Kubernetes API server keeps publishing these events, like which object has been changed, and all these other. You can think of it as like a distributed message queue only, right? It's put some event in the queue, and all these guys are subscribed to those queue, whoever are interested.